AI Multimodal Retrieval: How Senior Engineers Build Cross-Modal Search and Generation Systems in Production. Welcome back to Agentic AI World. I'm your host, and today we're diving into episode 60, AI Multimodal Retrieval. This is one of the hottest topics in the 2026 AI engineering interview circuit. If you're going for a senior AI engineer or principal architect role, expect this to come up. Let's set the stage. Multimodal retrieval means your system can take a query in one modality, say, text, and retrieve results from another modality, like images, audio, or video. Or you reverse it. A user uploads an image and asks a text question about it. Your system has to bridge those modalities intelligently. The naive approach fails immediately in production. You can't just embed text and images independently with unrelated models and hope cosine similarity does the work. You need a shared embedding space, a place where a photo of a golden retriever and an actual photo of a golden retriever map close to each other. That's where clip-style models come in. CLIP, Contrastive Language Image Pre-training from OpenAI, learns a joint embedding space by training on hundreds of millions of image caption pairs. At inference time, you encode text with the text encoder and images with the image encoder. Both land in the same latent space. Retrieval is now just nearest neighbor search across modalities. For interviews, here's the architecture you describe. You have two encoders, one for each modality. Both produce vectors of the same dimension. You store all embeddings in a vector database like Pinecone, Weaviate, or PVector. At query time, encode the query, run an approximate nearest neighbor search, and return ranked results. But here's where senior engineers go deeper. The interviewer will ask, what happens when your text query is ambiguous? Say someone searches Apple. Do they want the fruit or the company? In unimodal text search, you'd use query expansion or entity disambiguation. In multimodal, you can actually use the other modality to anchor intent. If the user uploads an image of an iPhone alongside their text query, suddenly the modality fusion clarifies intent. This is modality fusion at query time, and it's a key design pattern. You can fuse modalities early by concatenating embeddings before similarity search, or late by running separate retrievals per modality and re-ranking results together. Late fusion is generally more flexible and easier to tune in production. Let's talk about a real production scenario. E-commerce. A user uploads a photo of a jacket they saw someone wearing on the street. They type, similar but in navy blue. Your system needs to retrieve visually similar jackets and apply the color constraint from text. This is a cross-modal query with attribute filtering. The architecture for this: run image retrieval with the clip image encoder to get the top K visually similar items. Then apply a text filter, re-encode the attribute query, compute cross-modal similarity with candidates, and re-rank. You can also use a multimodal LLM to generate structured attributes from the image: brand, style, cut, fabric texture, then use those as metadata filters before semantic search. That hybrid approach is what FANG-level teams actually ship. Now let's talk about video. Video is the hardest multimodal retrieval problem because it adds the time dimension. A senior engineer's approach: you don't embed the whole video. You sample keyframes, typically one per second or at scene boundaries, and embed those. You also transcribe audio using Whisper and embed text chunks aligned to timestamps. At retrieval time, a text query hits both the keyframe index and the transcript index. You merge and deduplicate results, return the most relevant video segments with timestamps. This is exactly the architecture powering YouTube's semantic search. It's also what you describe if asked to design video search at scale. What are the failure modes? 3 big ones. First, modality gap. Even clip embeddings have a subtle gap between text and image distributions. Mitigation: use modality-specific temperature scaling when computing similarities and fine-tune the encoders on your domain data. Second, staleness. Your image index doesn't update as fast as your text content. In a product catalog, new SKUs go live every hour. Your multimodal index needs an incremental update pipeline, not a full re-embed on every change. Pattern: embed on write, push to index asynchronously. Use a message queue like Kafka to buffer ingestion events. Your vector store should support real-time upserts. Third, retrieval quality degradation at scale. At 1 million items, ANN search introduces false negatives. Senior engineers handle this with tiered retrieval, a fast approximate search for top 100 candidates, followed by exact re-ranking with a cross-encoder or multimodal re-ranker. The two-stage pipeline trades some latency for much better precision. For evaluation, you'd use recall at K. Did the ground truth item appear in your top K results? And mean reciprocal rank. Where in the list did the right answer land on average? Build an offline eval harness with labeled query result pairs across modalities. Run it on every model or index change before promoting to production. Interview tip: when they ask, how would you improve retrieval quality? Don't just say fine-tune.